You have f of x, you have g of x, and then you have, it says find f of x plus g of x. Well, if I want you to find f of x plus g of x, all I would do is use substitution. F of x is 3x minus 7. G of x is 13 minus 2x, and I'm just telling you to add those two together. So I would combine like terms. 3x minus 2x is x, negative 7 plus 13 is a positive 6, and that's your answer. Now, when you do functions, operations with functions, they don't put f of x plus g of x. What they do is they have it like this, f plus g. So think of distributive property, like you would take the x and multiply by f, and take the x and multiply by g. So basically, f plus g of x is the same as f of x plus g of x. If it has f minus g, that's the same as f of x minus g of x. Now, I want you to be mindful of this dot here. That, you know, means multiplication. And on the back side here, you're going to see something like this. That's an open circle. That means something completely different. So when you see just a closed circle, a dot, that does mean multiplication. But on the other side, it's going to be an open circle, which means something different. But if it's a dot there, that means times, so f of x times g of x. And then the quotient, f over g of x, is just f of x over g of x. Now, notice that there's a star here next to quotient. And the reason why there's a star is because most of these functions are polynomials, meaning they're going to have an x in it. And whenever you have a fraction, you cannot have what in the denominator? No, it could be negative. When you have a denominator, you can never have what number in the denominator? What makes it undefined? Zero, which means we have a restriction. Whenever you have a variable in the denominator, there's going to be a domain restriction. So when you see a quotient and you ever find a quotient and you have an x in your denominator, you must always put where the domain restriction is. From now on, moving forward, you always write the domain restrictions. Okay? Now, if it's just a polynomial straight across, there are never any restrictions. Only if it's like a square root or fourth root, you can't have a negative underneath the radical, and you cannot have, when you have a fraction denominator, having a 0. So let's go ahead and evaluate some of these. So we have f plus g of x. That is basically means f of x plus g of x. So we'll take f of x here, which is x squared minus 8x plus 4, plus g of x is 4x minus 3. Now, we are not solving, we are just simplifying. So we are going to combine like terms. So x squared, we can combine negative 8x plus 4x is negative 4x, and then 4 minus 3 is positive 1. And we're done.
Will we eventually find the solution?
Not when it's just left with x there, you're done. The only time you'll have a number is like on your quiz today when you have f plus g of 3. And we didn't have that. We have f of g of 3, but when you instead in parentheses have a number and not an x. Okay? I'll show you that in a little bit. So this one, f minus h of x, that's f of x minus h of x. So f of x is x squared minus 8x plus 4. You are subtracting, so what do you think you need to remember when you plug in x plus 2 for h of x? Whenever you are subtracting more than one term, you always have to do what? You have to distribute the negative. Good. So I would put h of x, since it's more than one term, in parentheses, and then you have to distribute the negative. So you have x squared minus 8x plus 4 minus x minus 2. So now if we combine like terms, we get x squared minus 9x plus 2. All right. If you look at number 1, are there any domain restrictions? Is there anything that x cannot equal? This domain is all real numbers. Whenever it's a polynomial, there's no radicals, there's no fraction there. It could be any, x can be anything. Your domain will always be negative infinity to positive infinity. Same with this one here. Your domain is all real numbers. Now, when you get to number 4, this is f of x divided by h of x. That's what that is. So f of x is x squared minus 8x plus 4 over 4x minus 3. There is nothing you can do. This is not factorable. There are no factors of 4 when you add what that will give you 8. Oh, that's h. You're right. Sorry about that, but thanks for catching that. Okay, so again, this is not factorable. There's nothing you can do. We are done. So dividing seems like it would be the hardest, but it's the easiest one because you just put polynomial on top, polynomial at the bottom. There is a domain restriction here because the denominator cannot equal 0. So for your domain, what can x not equal? 0 plus 2 is 2. That's okay. What can x not equal? Negative 2. So basically you take the denominator, you set it equal to 0 and solve. X cannot equal negative 2. All right, let's do number 3. We have h times g of x. So that's going to be h of x times g of x. H of x is x plus 2. G of x is 4x minus 3. So we do want to simplify it as much as possible, so we're going to need to FOIL this. So x times 4x is 4x squared minus 3x plus 8x minus 6. So we get 4x squared plus 5x minus 6. And this is all real numbers. There's no restrictions here. So let's do a division. H is x plus 2 divided by g of x is 4x minus 3. We're done. There's nothing to simplify here. Is there a domain restriction? Yes. You set the denominator equal to 0 and solve, because that's going to give you x, which will turn the bottom into 0. So you get 4x equals 3, divide by 4. X cannot equal 3/4, because 4 times 3/4 is 3. 3 minus 3 is 0. Now, let me see if we have one with numbers. Yeah. Okay, so let's go turn to this side here. Now, on number 7, we have f plus g of negative 2. So basically, we're going to distribute this negative 2, and it's going to be f of negative 2 plus g of negative 2. So now we're going to go to f of negative 2, which is right here, and we're going to evaluate this. So I'm going to go up here and say, all right, f of negative 2 equals 2 times negative 2 squared minus negative 2 minus 12. So what I did is every time I saw x, I plugged in negative 2. Well, negative 2 squared is a positive 4 times 2 is 8. 2 negatives will make that a positive. So 8 plus 2 is 10 minus 12. This is negative 2. Now, g of negative 2 is super simple because here's g of x. If I put negative 2 plus 7, that gives me 5. So negative 2 plus 5 equals 3. So you see on this one, you do get a final answer, which is a number. That's the difference between leaving this in x and actually having a number for your x. I took negative 2, g of negative 2, and I plugged it in here. So negative 2 plus 7 is 5. I found f of negative 2. It's a coincidence that f of negative 2 equaled that same number. Okay, f of negative 2, when I plugged it in, equaled to negative 2. Then I plugged in g of negative 2, which equals 5, because negative 2 plus 7 is 5. And I'm doing f plus g, so negative 2 plus 5 is 3.
Oh, I didn't see that. It was like adding.
Okay? All right, that's okay. So now let's do f times g of negative 1. That means we're going to take f of negative 1, and then we're going to multiply that by g of negative 1. So now I'm going to take my f of x function, and I'm going to plug in negative 1 for x. So I'm going to have 2 times negative 1 squared minus negative 1 minus 12. So negative 1 squared is a positive 1 times 2 is 2. That gives me plus 1 is 3 minus 12. This is negative 9. Now to find g of negative 1, I'm going to go to g of x, and negative 1 plus 7 is 6. So negative 9 times 6 is negative 54. Are you okay with those? Or do you need me to do another one? Okay, so like this one would be f of 8 minus g of 8. So you plug in 8 for x in your f of x function, plug in 8 for your g of x function, and then subtract the 2. Okay? Now, this is the open circle. Okay, compositions of functions, that's an open circle. Like this. That means something totally different. So what I want you to do is, when you have fog like this, that's the same thing. So if you have this, that basically means this. And that's what I showed you on that Friday. So that does not mean to multiply. What this means is you're going to take this function here, g of x, and put it inside the f of x function. So for those of you that were absent on Friday, I'm going to do 15 and 16 because 15 and 16 is what I showed on Friday. Okay? So when you have, but we didn't have the open circle, all right? So when you have g open circle h of 2, rewrite it as g of h of 2, like that. All right. Now, those of you who weren't here, when you are doing composition functions like this, you go and do what's on the inside first. So we find h of 2 first. Okay? So let's go find h of 2. So I'm going to go up here. If I plug in 2, what do I get here? I get 5 times 2 is 10 minus 3 is 7. So h of 2 equals 7. So what I'm going to do is I'm going to take h of 2 and I'm going to replace it with 7. And then I'm going to bring down g. So now I'm going to find g of 7. All right? So I took h of 2, and whatever that answer in, I'm putting it into the g. So g of 7. Well, g of x is x minus 1. So that means I'm going to plug in 7 for x. 7 minus 1 is 6. That's your answer. Now, for those of you who are here Friday, your only new part is when you see an open circle to rewrite it as a composition function like this. So now h open circle f of negative 6, we're going to rewrite it as h of f of negative 6. You really want to pay attention to this, especially if you weren't here. So what do you do first? Distribute. We're going to do f of negative 6. We're going on the inside. So f of negative 6. So we're going to go up here. And what's negative 6 to the third power plus 8? Okay, that's what negative 6 to the third power is. Now add 8 to it. Yeah. So this equals, I'm going to replace that with negative 208. Now I'm going to take negative 208 and put it inside of h. So h is 5x minus 3. So we're going to do 5 times negative 208 minus 3. Negative 1043. Okay, those are easy. This one is what gets a little tricky is when they leave it as x. So now we're going to follow with 11 through 14. Number 11 is the fog, the f, and the open circle, and the g. So let's rewrite it as f of g of x. Now you really want to pay close attention to this one. We go from the inside first, right? Well, what do we have on the inside? G of x. Do we know what g of x is? Oh, yes, you do. It's right here. What's g of x? So you're going to replace this with x minus 1. So what does x equal? When you plug it into the other equation, what are you plugging in? Very good. You are plugging in x minus 1. So we're going to go to the f of x equation, which is right here, the x cubed plus 8. Every time we see an x, we're going to plug in x minus 1. So now this is going to be x minus 1 cubed plus 8. And then I would have you FOIL that out, but just for our example, we're not going to do that. Because we always want to simplify it and make it as smaller as possible. Okay, let's look at this. Let's rewrite it as h of g of x. We're going to go from the inside, which is g of x. And we know what g of x is, that's x minus 1. So I'm going to replace this with x minus 1. Now, which function do I go into, f, g, or h? H. H is 5x minus 3. So I'm going to write over 5x minus 3. What does my x equal? X minus 1. So this is going to replace my x. So I'm going to have 5 times x minus 1 minus 3. Now we're not going to leave it like that because we can make this simpler. So we're going to distribute, then combine like terms. So if I distribute, we won't do this one. We'll just go down. 5x minus 5 minus 3. Which is 5x minus 8. And that's our final answer. But we are going to do this one and not that one. Go ahead and write over here g of f of x. What are we going to do first, g or f? F. So f of x is x cubed plus 8. And now we're going to go to g of x, which is x minus 1. So now we're going to take this and put it in place of x. And we always want to simplify, so that's going to be x cubed plus 7.